Here's a physics question about standing waves. It says an open vertical tube has water in it. A tuning fork vibrates at its mouth. I'm going to draw that in just so I have it in the diagram. See, those little lines means it's vibrating. As the water level is lowered in the tube, the fourth resonance is heard when the water level is 105 centimeters below the top. This is called an open, closed tube because one end is closed. The water forms a barrier. Essentially, that end of the tube is closed. Even if it's open below that, the water creates a close. So it's an open, closed tube. Now the question says, what is the wavelength of the sound wave? The speed of sound in air is 343 meters per second. Answer in units of centimeters. So there's this triangle: velocity is frequency times wavelength. Except I don't know the frequency at this point, so I don't have two of the three things. But here's another formula, and there's two versions of it. There's a version for an open tube, and there's a version for an open closed tube. For an open tube, the wavelength equals, let me remember this, 2L divided by N. For an open closed tube, the wavelength equals 2L divided by 2N minus 1. And this is when N is the resonance or the frequency number. So in other words, this says the fourth resonance. It says up here, water level, the fourth resonance. So that's the frequency number. That's the resonance. If the number given is a harmonic, then this formula remains the same for open. For open closed, if N is the harmonic, it's 2L. Oh, this is, wait a minute, I wrote that formula wrong. It's 4L. It's 4L divided by N, where N is the harmonic. And if it's a resonance, then it's 2N minus 1, where N is the resonance. So you got to be careful. Here's how it goes. Here are the resonances. 1, 2, 3, 4, 5, and on and on. Here's open, closed, the harmonics. For open, the harmonics are the same as the resonances. But for open, closed, it's only the odd numbers. So that's how there's differences. For example, for the fourth resonance, which is this question, the harmonic is 2 times 4 is 8, minus 1 is 7. The harmonic is 7. That's where this formula comes in, if you're using the resonance number. If you're using the harmonic, you just use N. So the first resonance is 1 for harmonics. The second resonance, the harmonic is 3. The third resonance, the harmonic is 5. The fourth resonance, the harmonic is 7. So you got to be careful because sometimes if you look online for these formulas, it'll give 4L over N, and it might not specify that N is a number of the harmonic. Often it does, but sometimes not. So if you have the frequency number or the resonance, for open, closed, open is always the same. 2L over N equals a wavelength. For open, closed, if you have the resonance, it's 4L over 2N minus 1. If you have the harmonic number, it's 4L over N is equal to the wavelength. I'm going to use this one because I don't want to have to think about the harmonics. It gives the resonance. It says the fourth resonance, so N is 4. I don't know why they don't do 2R minus 1 and in the other formula 4L over H. Don't know, but I'm just writing it the way it's done. So for the first one, it says, what is the wavelength of the sound length? Well, wavelength equals 4L, I don't know why I wrote 2 earlier, divide by 2N minus 1, where N is the resonance. So 4, the length is given in 105 centimeters. I don't have to convert because it asks for the answer in centimeters. Divided by, the resonance number is 4. 2 times 4 is 8, minus 1 is 7. And 4 times 105 divided by 7, well, let's see, 7 goes into 10 once. 35, 7 times 5, 4 times 15 equals 60 centimeters. For this one, the wavelength is 60 centimeters. I won't do 21, that's asking for the I won't do 20, that's asking for the frequency. But this is really about question 21. I just had to find the wavelength. Question 21 says, the water continues to leak out the bottom of the tube. when the tube next resonates. Well, this was at the fourth resonance, so now N is going to be 5 for resonances. I'll just abbreviate it. If I were using the harmonics, the fifth resonance is the ninth harmonic. But that's where the 2n minus 1. 2 times 5 is 10, minus 1 is 9. So I'm going to use the formula given the resonance number of 5. If I was using just 4L over N, I'd use 9 because that's the harmonic. So I know that the wavelength equals 4L over, using resonances, 2N minus 1. And I want to find the length. So I'm going to multiply both sides by 2N minus 1 times the wavelength. And I'm dividing both sides by 4 equals the length. And I'll do this one other way just to show. All right, so the resonance is the fifth resonance. That's the next one. 2 times 5 is 10, minus 1 is 9. The wavelength is 60. Divided by 4 equals L. 4 goes into 16 15 times. 9 times 15 is 135 centimeters. Now let me expand this page just a little bit because, I can't expand this page. I thought I was in a different program. I need to find a blank space. Another way, I guess I'll do it up here. Another way is I could write the L at one resonance equals the L of the length of the previous resonance plus wavelength over 2. Now some people write this as the length equals the initial length plus N minus 1 wavelength over 2, where N is the resonance number. But I know that at the fourth resonance, the length is 105. So this is the fifth resonance length equals the fourth resonance length, which is 105, plus the wavelength, I might as well put it in, 60 divided by 2. And that equals 135 centimeters. Same answer I got using that formula. I got with this formula. But remember, in this case, I do not know the initial length. All I know is the length at the fourth resonance. If I knew the initial length, I could add plus 5 minus 1, which would be 4, times the wavelength divided by 2, and I would find the length at the fifth resonance. Or this is like the iterative version of the formula. The length at a certain resonance is equal to the length at the previous resonance plus the wavelength over 2. And it comes out with the same answer, 135 centimeters in this case.